These are the various passive electronic components we're going to understand today. But first, let's talk about what passive components actually are. They're the essential building blocks that make circuits work. But unlike active components, they don't generate energy on their own. Instead, they control, store, or filter the flow of electricity within a circuit. These quiet, behind-the-scenes parts form the foundation of all electronic devices. Now let's explore each one step by step. A resistor is an electronic component that controls how much electric current flows through a circuit. It does this by resisting the flow of electricity, converting some of that electrical energy into heat. By doing so, it helps other components receive the right amount of current and voltage they need to work properly. You'll find resistors in nearly every electronic device, from LED lights to computers. There are basic fixed resistors, which always have the same resistance, and variable resistors, also called potentiometers, which let you adjust the resistance manually. Potentiometers are perfect for things like volume knobs, light dimmers, and tuning dials. Resistors are simple, reliable, and inexpensive, but it's important to note that they can't store energy or amplify signals. Next up, we have capacitors. A capacitor is a component that stores and releases electrical energy when needed. It holds charge in an electric field between two conductive plates separated by an insulator. Capacitors are used in circuits to smooth out voltage changes, provide quick bursts of energy, or control timing. Small ceramic capacitors are often used in high-frequency circuits, while larger electrolytic capacitors are common in power supplies. They're fast, versatile, and absolutely essential for almost every electronic device. Now let's look at inductors. An inductor is a coil of wire that stores energy in the form of a magnetic field when current flows through it. It resists sudden changes in current, making it useful for filtering signals and managing power. Inductors are found in radios, filters, and power circuits, where they regulate current and block unwanted frequencies. Air core inductors work well for high-frequency applications, while iron core inductors are used in power circuits because they store more energy. Inductors play a key role in keeping circuits stable, though they can be a bit bulky and slow to react to rapid current changes. Moving on, we have thermistors. A thermistor is a type of resistor whose resistance changes with temperature. Its name comes from thermal and resistor. There are two main types: NTC thermistors, which have a negative temperature coefficient and decrease in resistance as temperature rises, and PTC thermistors, which have a positive coefficient and increase in resistance as they get hotter. Thermistors are widely used for temperature sensing, circuit protection, and current control. They are precise and responsive, but work best within specific temperature ranges. Now let's talk about varistors. A varistor is a voltage-dependent resistor that protects electronic circuits from sudden voltage spikes or surges. Its resistance changes based on the amount of voltage applied. Varistors are commonly found in surge protectors and power supplies. They're simple, effective, and reliable, though they can wear out after repeated voltage surges. Next, we have ferrite beads. A ferrite bead is a small passive component made from ferrite material, designed to block high-frequency electrical noise. It works by converting that noise energy into a small amount of heat while allowing normal current to pass. You'll often see ferrite beads on USB cables, power cords, and circuit boards to prevent interference and keep signals clean. They're simple, inexpensive, and essential for maintaining stable operation in modern electronics. Now let's look at crystal oscillators. A crystal oscillator is a component that creates precise and consistent electrical signals using the natural vibration of a quartz crystal. When voltage is applied, the quartz vibrates at a fixed frequency, producing an accurate timing signal. These oscillators keep devices like computers, smartphones, and watches running in perfect sync. They don't directly measure time, but their steady frequency lets circuits count vibrations and track time accurately. Their precision is excellent, though they usually work at fixed frequencies, so they're not adjustable for multiple timing needs. Finally, we have filters. A filter is a combination of passive components, resistors, capacitors, and inductors, arranged to control which frequencies of a signal can pass and which are blocked. Filters are vital in audio systems, radios, and signal processing to remove unwanted noise and refine signals. So, these were all the passive electronic components. If you're still watching, consider subscribing, because in the next video, I'll be explaining all the active electronic components. And if you have any feedback or suggestions, Feel free to share them in the comments below. See you in the next one.